working with the CSV file. So so this is the CSV file that's provided, and we're gonna working with the H column today right here. So we're gonna close it. So we're gonna import the pandas as PD, import the numpy as NP. The pandas is, so the panda is a Python library that gives you a fantastic set of tools to do the data analysis. So the import pandas portion of the code tells the Python to bring the pandas data analysis library into my current environment. So the SPD part of the code then tells the Python to give a pandas the alias of PD. This allows me to use the pandas function by simply typing the PD. So the numpy can use to perform a wide variety of a mathematical operation on arrays. So the pandas dot read CSV, and then the code slash content slash biostatic dot CSV. We're gonna read the file from the accurate location, which is right here. So we're gonna print it. So the data is gonna be the alias. We're gonna print the data right here. It looks like this. So for the age, so we're gonna fetch the age column of the dataset as an array. So we run it first. Yes. So we're gonna fetch the age column of the dataset as an array. So the np dot array are faster and more compact than the Python list. An array consumes less memory and is convenient to use. So this one, and also print, return the column of all of the age in an array. So we're gonna print it out as an array print. So next we're gonna working with the average, the standard deviation, the minimum, and the maximum of the array, and prints the result. So first one, we're gonna work with an np.average. The np.average function computes the weight average of element in an array according to the respective weights given in another array. To find the mean of a numpy array, we can use np.average statistic function. This way will be manipulated with the value, and then the mean of the resulting is calculated. So now we got the average. So for the standard deviation, so we use the np.std as an alias. So the function returns the standard deviation of the array element. So the square root of the average square deviation, which is computed from the mean, is known as the standard deviation. 30%. Yeah. And then next one, we're gonna working with the minimum and the maximum. So those two is very similar. So the np.max is the tools that give you you need to for finding the maximum value or the value in a single array, and the minimum, so we're gonna finding it, so and then we're gonna print it out, finding the minimum value, so in a single array. So we print it out again. So this is going to be the result. So we're going to working with find the 30th percentile median and the 70th percentile of the age column. So the 30th percentile means that the 30% of the people are 30.1 years old or younger. So the 50 mean that the 50% of the people are 32.5 years old or younger, and then 70% as well, the same thing. So the median is a 50%. So the percentile function allows the following parameter, which is an array, which is the age, and then the percentile are used right here in the statistic, give a number that describe the value and given the percent of the value are lower than. So now we're gonna like draw a histogram chart. So we import the matplotlib pyplot as a PLT and import the seaborn as SNS. So the pyplot is a collection of the function in the popular visualization package matplotlib. Its function manipulate the element of a figure, such as creating a figure, plotting line, adding plot label. So we're gonna plot the data to histogram chart right here. And the seaborn is a library for making the statistic graphic in Python. It builds on the top of the matplotlib and integrate closely with the Panda data structures. It provides a high-level interface for drawing attractive and informative statistic graphics. So for next one, we're gonna working with the SNS.sat. So it applied the default seaborn theme, scaling, and the color palette. The PLT histogram is gonna create a histogram bar chart of the element in a vector of age right here, a set of age. So on the vertical axis, place the number, label this axis number. On the horizontal axis, place the lower value of each interval, and label this axis with the type of the data. So drawing the bar extending from the low value of each interval to the lower value of the next interval. So the PLT title, we're gonna like put it on the top of the title, and then the X label, we're gonna put it in the X axis, X label. The Y label, we put it right here. So that's everything. We're gonna print it. Okay, thank you so much.